Welcome to the video of trigonometry functions, the late night edition. It's about 10:30, so I'm trying to keep my voice a little soft because I don't wake anybody up because everybody else is in bed. And it probably won't be an exciting video because it is at 10:30 and it's late, so probably won't have a whole lot of energy. But every once in a while you may hear my cat meowing in the background because he's just annoying. Okay, so let's go ahead and jump into what we call the sine, cosine, and trig functions. When we talk about the sine, cosine, and trig functions, a couple of things that people have used to try to memorize how to set these up. One of them that you probably heard of, or people may talk about, is called SOHCAHTOA. Okay, another way, and this is one way to try to memorize how to write this. Okay. Another way people think about it, or I've stolen this from Miss Smith, is another way to think about it is some old, I can't even spell old, some old hippie caught another hippie tripping on acid. I know what you're thinking. I know what you're thinking about. Like, what? What is all this? What tripping acid? What? Okay, this is one way to possibly think about how to set up when it comes to sine, cosine, tangent. You'll notice too, the beginning of each letter is very similar to what you just saw up top here. Okay, S, S, O, O, H, H. Some old hippie. Then you have caught another hippie tripping on acid. Okay, so the beginning of each letter basically spells SOHCAHTOA. And you're still probably thinking like, well, okay, there's two things here you just showed me. I don't even know what either one of these means. Okay, so we're dealing with right triangles, and this is how we find the lengths of the sides and things like that. Okay, so the SO part is sine equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And then the TOA is the tangent, which just basically is just tan. The tangent of an angle is equal to the opposite over adjacent. Okay, so now what you're probably thinking about is, well, what does all this mean? Opposite hypotenuse, adjacent hypotenuse. So what we're going to go is basically if you have a right triangle, okay, and we're dealing with, let's just call this A, B, C. So let's just say we're dealing with angle C here, okay? So if we want so from this angle, that's the location that you always deal with, is the location of the angle. So with the location of angle C, the sine, okay, if you refer back to the other page, sine is opposite over hypotenuse. Well, before we get into that, let's talk about what all these things are. Okay, so we're dealing with angle C we talked about. So the hypotenuse, remember, is always the one that's directly across from the right angle. Okay, so this side is going to be the hypotenuse. Okay, from here we're going to talk about the opposite and adjacent. Now, opposite is talking about the side that is opposite of the angle that we're dealing with. Okay, so remember, this is the angle that we're dealing with. The side that's opposite is over here. So that's the opposite. The adjacent means right next to. Okay, so what is the side that is right next to angle C? Okay, right next to angle C. Well, it's this one here. That's the adjacent. Now, technically, the hypotenuse is also adjacent, but we don't call the hypotenuse adjacent, it's the hypotenuse. It's always going to be the one directly across from the right angle. Okay, so if we just so happen to had another right triangle, A, B, C, and we're dealing with this angle, okay, this is still the hypotenuse. Now we go directly across, this is the opposite side, and then the one right next to this angle is this one, the side AB, so that's your adjacent. Okay, so let's move back up to this top red triangle. Sine is opposite over hypotenuse. Okay, so let's just, for example, if we had, this would be 4, 9, and 11. So the sine of this would be opposite over adjacent. Okay, so that would be 9 over 4. Okay, so now let's talk about the cosine. The cosine of the angle C is equal to adjacent over hypotenuse. If we go back, and it's adjacent over hypotenuse. So when we go back, the adjacent is the 4, and the hypotenuse is the 11. 4 over 11. So now let's talk about the the tangent. So the tangent of C, and if we go back, tangent, it would be this one here, and it's opposite over adjacent. So the opposite of angle C is 9, and the adjacent is 4. Okay. Now, if you notice in my sign up here, I made a mistake. Okay. Really, it should be opposite over hypotenuse. I put opposite over adjacent. Let's fix that. So really, the opposite over hypotenuse would really be 9 over 11. Okay. So that's about how we're going to do this. So now let's follow along in your assignment or your flip book that you've put together. Sorry to break the bad news to you, but there probably is going to be more than one video on here. The software I'm using only records up to so much time, so I'm going to try to go through this maybe a little fast, and if it goes through fast, you can always pause it. Again, sorry about this, but I don't want you guys to miss out on a day just sitting around doing nothing. So we're going to try to get some stuff done. Okay, so sine, or so, we have here. So we have sine is equal to opposite over hypotenuse. Okay, so if we look at our practice to the right, okay, so the opposite, so we're talking about sine A. So sine A is this right here. So based off of sine A, this is the opposite, this is hypotenuse, and the 5 is the adjacent. Okay, so if we did what it tells us to do, opposite over hypotenuse, we end up with 12 over 13. So then on practice B, you'll notice that we're talking about this angle. So when you're talking about that angle, this becomes the adjacent, this becomes the opposite, the 5 becomes the opposite, and the 13 remains to be the hypotenuse because hypotenuse never changes. So if we go from sine, which is still opposite over hypotenuse, then this time it would be 5 over 13. Because we're dealing with the location of B. Opposite is the opposite of, the 5 is opposite of the B, and the hypotenuse is still just a hypotenuse. So let's do finding sides on example 5 here. So we have angle 41. So this is our location. Okay. So directly across the side across, or on the other side of the 41 is the opposite. So we have sine of the angle, which this angle is 41, is equal to, remember, opposite over hypotenuse. Okay. So in this problem, we have sine 41 is equal to opposite, which is x, over hypotenuse, which is 17. Okay, just like normal solving equations, we want to try to get x by itself. Okay, so in order to get this x by itself, we need to get rid of the 17. So we would multiply both sides by 17. That cancels out. So then we have 17 times sine 41 is equal to x. Okay, that's what you're going to type into your calculator. So if we go over here and type into your calculator 17 times sine 41, close the parenthesis just for good practice. You could get away with not putting the end of the parenthesis, but just good practice, go ahead and put it, hit enter. So that side, if we rounded, it would be about 11.15, or 11.2 actually. So we'll just say it's approximately 11.2. That's what x is going to be in this problem. Let's look at example 6 now. In example 6, we have the location is right here. So from this location, this is the opposite, the 29. The x is the hypotenuse. Remember, the hypotenuse is always directly across from the right angle. So we have sine of the angle, which is 73, is equal to opposite over hypotenuse, which in this case is going to be 29 over x. Okay, so I have sine 73 is equal to 29 over x. Now, one way we could do this is, once again, if we want to get rid of the denominator, we got to multiply both sides by the denominator. That cancels out, so we end up with x times sine 73 is equal to 29. Okay, to get x completely by itself, we'll do the opposite of multiplication and we'll divide. So then you end up with x is equal to 29 over sine 73. So that's what you're going to type into your calculator. Okay, so we have 29 divided by sine 73. Close the parentheses, hit enter. Okay, so we end up with approximately 30.3. Okay. Now, something I forgot to tell you before is you got to make sure your calculator is in degree mode. How do you do that? You go to mode, and you'll notice right here it's highlighted in degree mode. Now, if it's in radian mode, okay, all you have to do is press down, click over to degree, hit your enter button. Now it's in degree mode. Okay, to get out of there, second, and mode, which you see in blue, it's labeled as quit. So we get out and things like that. Okay, so mine was already low. I knew mine was already in that, so I went ahead and did it, and it's correct. Okay, so let's go back and notice, like I said, so this hypotenuse is roughly going to be about 30.3, whatever it may be, units long. Okay, I think I'm going to stop this video right here because I'm about to run out of time. I'm going to start a new one.